In this video, we're going to talk about linked lists. Linked lists are a basic data structure which is a list of objects that are arranged in a linear order. This may sound like an array, but the difference is that order is not maintained by consecutiveness. So the way we manage this is we have what's called a node. Each node has a piece of data. The piece of data and a pointer to the next node. Okay? And it's as simple as that. We end the list with a null. So here the way we define it is we define our node data type, which would have our piece of data and a pointer to the next node. Then our list would just be a pointer to the first node. Now the advantages to this, some of the downsides and upsides, it does not allow for random access values. You cannot easily say show me the fifth element without having to move all the way through them. However, if you imagine an array and you want to insert something at the first position, you've got to move everything down. Or if at the fifth position, you've got to move everything past it down. Similarly with deleting. It doesn't have that problem with a linked list. They do require more memory because you've got to have a pointer to the next element. However, they aren't size bound like arrays. And for example, what they're good at is adding or deleting element at the beginning or maybe end of the list is fast. Adding or deleting an element anywhere else is good. Searching is bad because on average you have to go through half the list. And access time for an element in the list is bad because you have to access to the proper point. So here's a way to look at it. We've got our head, start of list pointer, and the object data. And here we have a pointer to the next item and so forth. So let's look at how to insert an item. So here we create our new node 3, okay? And we want to insert it at the beginning of the list. Well, all we have to do now is make its next pointer point to the head of the list, 39, and then change the head of the list to now point to 3. Boom, we've added it. No surprises. Inserting at the end, what we need to do is create the new node, find the pointer to the last node, look at its next value, make its next value here point to 3, and then make the 3's next pointer point to null. Now this can be made a little faster if you keep not only the head but the tail of the list. If we want to insert in the middle, we find our insertion spot. And now what we need to do is 23's next pointer will now point to 3. And 3's next pointer will now point to 21. And boom, we've inserted in our list. If we want to delete in the beginning, it's really simple. We grab the first node, we delete it, and then we set the head of the list to point to the next node. To delete at the end, similarly, we just grab the last node, the one before the last node, set its pointer to null, and then delete the former last element. In the middle, we basically have to find the next node, the previous node from the one we wanted to delete, and set the previous node's next element to the item we want to delete's next element, which knocks it out of the loop, and then we delete this guy. A little bit about doubly linked lists. One way to make it more effective is we could have a linked list with